Hello there and welcome. Learning to debug your code is one of the most crucial skills you can acquire as a software developer, especially when it comes to creating games in Unity. As beginners, most people start by following tutorials, learning Unity and coding as they go, but when something goes wrong, something that is not covered in the tutorial, they often find themselves completely lost, unsure of what to do next. That's why I've decided to create this guide. My goal is to show you the general process of debugging in Unity and to equip you with the tools and knowledge to handle and fix the next bug you encounter on your own. Before diving into the debugging process, it's important to understand that there are two main categories of errors you might encounter: compiler errors and runtime errors. So let's break them down. Compiler errors occur when there is an issue with how your code is written, specifically problems with the syntax. These are typically easier to fix because the code editor will point out exactly where the error is. For example, forgetting to add a semicolon or mistyping a word, or maybe just if you forgot to place a curly brace. What will happen is that the code is not going to be compiled and it will prevent your game from running at all. In Unity, it will also prevent from the other code to be compiled together, and you won't see any changes in the inspector until the problem is resolved. Of course, we're going to see all of these examples. Runtime errors, on the other hand, happen while your game is running. These are often more challenging to debug because they involve the logic of the code or issues with Unity components and systems. For example, you're trying to access an object that was not instantiated, or maybe a script that is not behaving in the way that you planned, that it causes some kind of problem. Now, these will not prevent you from running your game, but the game can actually crash or just stop performing the way you want it to. So when we get an error, the first thing we need to understand is if it's a compiler error or a runtime error. So let's talk about compiler errors. If we go and open our Visual Studio Code, it's very important, first of all, to make sure that we got auto-completion on. We have IntelliSense. So IntelliSense is when you type some kind of variable and it gives you different options. And then if you want to find another thing, it will give you all of these options, get component, and it will actually give you the different components and options in Unity that you can add. In this way, you don't have to guess and type it out by yourself because you may have an error with the spelling, and this will cause you a compiler error. So just make sure that Visual Studio has IntelliSense installed, and usually it comes automatically when you install a fresh copy of Visual Studio. But if you don't have IntelliSense after you installed Visual Studio, it means that something is wrong with the installation. You may try to install it again, or you can just go to Google and search for troubleshooting with IntelliSense. Another reason you need to use a good code editor is because it gives us a lot of important information. If you're just going to use a simple text editor to edit your code, you're going to get in a lot of trouble. Because let's say we forgot the semicolon. We already see this red warning over here that tells us that there is something wrong with the syntax. We can even go over here and look at the right side and we can see this little red dot. So if we go to this little red dot, we can know that there is a problem at this point. If we had another problem over here, we would see another problem at the bottom. So this way you can know that you have a problem with the syntax, something is missing, something is not right. So we can go over here and add the semicolon also over here, and now we don't have these errors. That's why it's very important to have a good editor. Now obviously there won't be any errors if you type a string word. For example, instead of saying world, you say something like that, right? There won't be any problem with the code because this is a string and you can type whatever you want. This is basic knowledge in programming. So this is not an error. This is just a way you decided to display your text. But when we're talking about components and variables, it's important that everything is spelled correctly. Even if you have a variable, of course, you can decide to name it whatever you want. You can name it text, you can name it txt, but if you're trying to use this variable, it's important that it's spelled correctly. Otherwise, you're going to have an error and the code won't compile because it doesn't even know which variable you're trying to use. There's no variable. You can also hover and it says the name txxt does not exist in the current context. It means there is no variable with this name. You need to make sure that this is the exact same. Now, if you would use a simple code editor and you had something like that, you won't even know that there's a problem. And let's see this. If I open this hello world inside my Explorer, and then I open it with a simple text editor, this is the way it's going to look. And you can see that there is no indication for anything. You cannot see any errors, so I can do this, I can do whatever I want, and I won't even know that there is some kind of typo or that there is some kind of mistake. This is not the way to work with code. So before you even try troubleshooting, please get yourself a code editor. It's free. You don't need to pay a cent. Just download it, and when you install Unity, it offers you to install Visual Studio. Obviously, you don't have to use Visual Studio. You can use Visual Code, you can use Atom, you can use other code editors, but don't use a simple editor that is not providing all of these different functionalities, because this is just a bad idea. Now, let's say, for example, we have this error over here, or even just forgot a semicolon. We may have a very long code, maybe 1,000 lines of code, and we will forget this thing and we won't even notice that there is some kind of error. We're going to save the code, right? We save the code, Control S, or maybe we go over here and we save everything. Once we close this, we're going to see an error inside the console. That's why it's a very good idea to always have your console opened like that. So let's say we close the console or we lost it, we simply go to Window, General, and we have console over here. So it's always a good idea. I always keep it at the top like this so I can see all the errors. This is sometimes not very visible. So we got this error. And this is just because we saved our script and there is some kind of compiler error. Because once we save the script, Unity will start compiling the script just to make sure that the inspector and all the data is updated, right? If we do a change, we want to see the change in the inspector as well. But at this point, it's not even going to make these changes because there is a problem. But it gives us a lot of information, and because we have this error, we won't be able to start the game. So if I press over here and start the game, it will tell me all compiler errors have to be fixed before you can enter play mode. So we get all the data that we need over here. And we know that we have this one problem, and it even tells us where is the problem. So it's very easy to fix compiler errors. It tells us that the problem is in assets, hello world, CS. It means that it's a script, right? We have this hello world script over here. And then it tells us that it's on line 20 at the 40th to position. And it even tells us that semicolon, you can see the semicolon over here, is expected. So it's not only telling us where is the problem, it even tells us what is the problem. But if we don't even look at this, we can go to this exact location and we can see the problem. So if I take the code editor, we can see line 20. So I simply go to this script and we have the line number over here on the left. So if I scroll to line 20, you can see line 20. I start counting, so 42. I mean, yes, we can see the problem right away. But if it's a bit more complicated, we simply start counting 42. So 1, 2, 3, 4, 5, 6. I don't know why it tells us 42, but it means at the end of this line, and we can already see this problem, and we can even see it tells us semicolon expected. And now if we save the script It's going to compile it, and we can see this loading logo, and it will go away. So now we can clear everything and we can actually run the game. Now, if you did some kind of change in your code for something related to the inspector, for example, we added another field, so let's say public bool is playing. If we have an error after we save the game, but before the code was compiled, we are not going to see these changes in the inspector. So let's say we had some kind of error over here, and then we save the script, right? Save all. And then we would go back over here. You will see that we get this problem, but we don't see any changes in the inspector because the code was not compiled and Unity did not change the inspector to contain this bool. Only when this is going to be resolved, we're going to see the change over here. Now again, we can see the same thing. We have a problem in this script. So if you have 100 different scripts, it doesn't matter. You are going to find the name of the script, the exact line and location. And then it tells us the name txxt does not exist in the current context. Another thing we can do, we don't need to go and start looking for the exact script. Even if we have 100 scripts, we can simply double click on this and it will open the code editor and it will bring us to the exact line. So it's very easy to fix compiler errors. Now we can see that there's a problem over here and we can simply fix it. And now when we save the script, it's going to think a bit, it's going to compile, and now we can see this Boolean appearing over here, and now we can also run the game. Now let's talk a bit about debugging runtime errors. This is, let's say, what we spend 90% of our time debugging, and these bugs can be annoying and it can even take us hours and even days because of these bugs. Now usually when you have more experience and knowledge, you find the error rather fast, and then it's just about fixing the bug or maybe changing the logic, so this takes more time, but usually it's rather fast to find the problem here as well, because we do have the console and we have a few other tools. In case you have a runtime error, the editor is not going to help you because you're not going to see any kind of indication to this error. A runtime error is a problem with the logic itself. So maybe you're trying to do something that is simply problematic and then your code is going to crash the game, or the game will be stuck, or it will simply be some kind of bug. So maybe the game is not going to crash, but your player is going to walk backwards instead of forward. And that's exactly the difference between an error and a bug. An error is when you actually get an error inside the console. There is a problem. Maybe the game crashes. Maybe something is stuck. A bug, on the other hand, is when the code is not running the way you want it to. The game or the application is not running the way you want it to. And it doesn't mean that there has to be an error. So a bug is not an error and an error is not a bug. These are two different things, but we still call it debugging because we are trying to fix something with our code. Now, when we try to debug a runtime error, it's important to have a basic knowledge of Unity, of C# or the programming language that you're using, because the problem will be in the actual logic and not with some kind of syntax. Although it's important to know the syntax of the language, otherwise you're going to have compilation errors. So let's see an example. If we go to our code, and this is a very unimportant script that simply changes the colors of the text, we can see that we have a text component, we have a variable for the speed, and we have this bool that we created. Then we get the component and store it inside this text. And then we do a few operations. We also set the text. Now, the most common number one runtime error is a null pointer reference. And it simply means that Unity expected something and it did not find it. So for example, over here, we have this TextMesh Pro component, and at this point, we're making it public so we can actually drag it into this slot and make the reference manually. So this is actually pointless because it does the operation for us again. So we can delete this and nothing is going to change. But let's say that we did not drag the reference over here into the inspector manually. Let's say this is empty. The code will start running. The start method is going to run. It will expect the reference to be over here, and then it will start running the code and it will try to do something with this text. It will try to add the string to the text. It will try to do something with the text. So we don't have a reference to this text because it's empty. And this will cause a runtime error. So it will allow us to run the code. We're not going to see any kind of indication over here. You can see we have no red lines. We have no errors on the right side. Everything looks fine. We can save the file. We can even run the game. But when the game will start running, we're going to get an error and it will tell us that there is a null pointer reference because it expected us to add something over here and then it tried to do something with this text, but there was no text. And of course, there's a million variations to this. Maybe it's some kind of list, right? Let's say a public list of strings, my names, and then it will try to, let's say, and we try to access an index, for example, index 1, and we try to, let's say, we try to set the first index to be the text. Now we're going to get an error because we know for sure that there are no strings inside of this list. And there's obviously nothing in the first index because there's nothing in 0, there's nothing in 1. The list is completely empty, but we're trying to access a specific index. So let's save it. And again, we can see that there are no errors inside the code itself. But if we try to run the game again, we can see another type of error. And it tells us argument out of range exception. Index was out of range, must be non-negative and less than the size of the collection. So the problem was that we tried to access this index inside of this list, but the list is empty. And it tells us must be non-negative and less than the size of the collection. So if we had 2 elements, it would work because we're trying to access element 1. So we try to access this. If we had 2 elements, it would not be a problem. If we had 3 elements, we did not have the problem. But if we had 1 element, we would have the problem because we're trying to actually access the second one, right? Because in programming, it starts with 0, 1, 2. So we're trying to access the second one, and we don't have a second one. We only have the first one. If we try to access the first one, then there would be no problem. But because this was empty, we got an error. So we can see that if we have 1 element and we try to access this 1 element, there would be no problem. Also, if we use a negative value, obviously we're going to get an error because this is not allowed. So runtime errors are a lot about out of range problems, about null references, about wrong logic. Now, let's say we delete this and we go to the next problem, which was the problem with the null pointer reference. We're going to save. Everything looks fine. When we run the game, again, it's going to give us this problem, null pointer reference. There is no reference to this text over here. We can also double click on it and it will bring us here. And we can see that it tries to do something with this text, but there is no text. Only when we actually drag the text over here, it's going to work. Now, another aspect of debugging is actually handle situations where we want to prevent errors from happening. So if we did something like that in the start method, we would simply say if text equals null. So if the text doesn't exist, then we can print something and say text is missing in the inspector. So now, if this will be empty, we're still going to get the error, but we will know exactly what is the problem. And this is maybe the most important tool in debugging, the debug log. You can basically print data to the console in different parts of the code in different situations. So instead of going and looking at this error and trying to understand what is the error, you can simply give yourself some information. And now when this is going to be empty, for example, I'm going to forget to place this over here and I'm going to run. We're going to get both the actual error, but we're also going to get our debug log that will tell us text is missing in the inspector. And then we will know, oh wait, yeah, I forgot to add the text. I already know what is the problem. Now, besides providing ourselves with information, we can prevent this error from even happening. So for example, we can simply print this thing over here and then do else. So if the text actually exists, we're going to do this. And there's probably going to be this problem because the text also exists inside. So let's say everything over here. And now, obviously, if the text doesn't exist, then nothing will happen with our script, but we are not going to get an error. Now, if the text exists, then everything will happen because we said else. So now we did not fix the problem, right? But if we run the game, we're not going to get any errors. There will be no crashes, but the code is not going to work because nothing happened, right? Only when we place the text component and it's not null, we're going to run this code. So this is a way to prevent crashes. It's a way to prevent errors, although it's not going to actually help us resolve the problem because the code is simply not going to work. But imagine you have a huge game with a lot of components and maybe there is some kind of functionality that is optional and something went wrong. You don't want your entire game to crash because this one small functionality is not working. You simply want to say if it's null, then don't do anything and just print the error to the log. But if it is working, then actually run the code. Otherwise, the code will crash over here, and it will crash over here, and it will crash inside of this coroutine because we use the text over here. So instead of this, you can prevent everything. And this is not a fix, but it's a way to prevent errors in case we forget the text. Now let's go back. This is pretty straightforward. We can see that there is this one component that is missing, and then we get the notification inside the console that tells us there is a problem on line 14 or line 16, right? But what if it's a bit more complicated? What if we had a very long line and we didn't know exactly where is the problem? For this, we could use the debug log to actually debug our code and not just to provide us with information. For example, if we had some more references, we can say something like debug log, and you can actually use different logs. You can say debug log, you can use debug log, debug warning, log warning, and debug log error. And each one will give us a different kind of error, well, a different kind of console print. So we can basically make things just plain gray like this one, and we can make things warnings, and we can make things errors. So you can see the difference when I run it. So now we can basically, instead of typing out and saying something, there is a problem, we can actually take this component and do something with it. If we had a value, we can simply say public, or if it's private, int something like value, and then we had some operations on this value. We could print the value and see the value at this point in time. And maybe the value was null, and that's what caused the problem. So this is a way to actually debug the code. You can print values, you can print different data into the console and see if there is a problem with the actual value. So let's say we got this text, and now we can say, let's print this. So instead of checking if text is null and then print something, text is null, we can simply print the text itself, and we are going to know what is the status with this text. When I say text, I mean text component, right? Text, because it's not the actual text, it's the entire component for the text, right? This one. So now if we run the game or the program, we're going to see these three kinds of logs. They simply differ in color and they stand out for the eye, but we're going to get information about this component. So now when we run the program, we can see the three different types. This is a regular log, this is a log warning, and this is a log error. This is the actual error that we get from Unity, but these are the things that we printed. So what we see over here, we see log warning, log error, but it tells us null. So we can know that the text component is null. And this is a very good way to debug our code by printing information using the debug log. And of course, if things got a bit more complicated, for example, we had some kind of loop with different indexes, we can try to figure out at this point in line what is the value of I. So we can print over here Debug.Log, the value of I is, and then add the actual value of I, and then for each loop it would print this and we would know what is the value, and this would help us to figure out what is the problem. So now if we run the game, obviously we're not going to get to this part of code because we don't have this reference, so let's add a reference. Let's start the game again. And now we can see that it was printed. I is 0, I is 1, 2, 3, 4, 5, 10, 0, 1, 2. And then you can also print something like, this is a new character, and then it would print this and also print the value, and then it will print this again. So you can actually create an entire block of messages to yourself to debug the code. And let me tell you that most of the real hardcore debugging is solved using the debug log by actually extracting values and data from the code onto the console and then debugging it. This is 90% of the real debugging, so you really need to use this. It's very beneficial to also simply have these debug logs all around your script to look at the main flow. Obviously, eventually just remove them because you don't want this extra line of code to keep running when you finally publish the game. So if you don't need this anymore, just delete this. But you always want to be notified. You want to have as much visibility as you want for the way your code is working. Let's say also you have a very long line with different components, and then it tells you that there's a problem on line 50. How would you know if the problem is with this text info, or maybe this mesh info, or maybe this colors 32? You can simply use Debug.Log, let's say before the error over here, and then you can check for this, and you can check for this, and you can check for this. Obviously, it's not going to work this way, so we need to use this, and over here we can use this. And now when we run the code, we can actually see the value for each one of these. So if we had a null pointer reference on line 54, we don't need to actually guess all of this. We can simply see these debug logs, and it will tell us that this value is null, right? Or this value is null. And this is a very good way to debug your code. Now, there are a few more things that you can use in Unity to debug the code. For example, the breakpoints. You can select this thing and then run the debugger. But I personally don't use it because most of the time it's not even that helpful. I can manage everything using the debug log. So also sometimes it just doesn't work. Sometimes it gives me a lot of headache. I just don't recommend this. I mean, you can look up a tutorial about this, but I assure you that using debug log, using the console, using basic knowledge to understand your problem is the way to go. And what will this do? It will basically run the script the same way the game will run it. So it will go from this line to this line and then this line, and then you will be able to see the different values. But you can do the same thing by simply writing debug log and then inserting the value just like I showed you. So I'm not going to explain about this because I personally never use this. I never needed to use this. I never found a reason to use this. And I still managed to debug all of my errors, all of my problems with debug log and with the console. So I think that you can do it by yourself, and eventually debugging Unity is not that hard. First of all, we decide or we understand if it's a compiler error, and if it is, then it's a very easy fix. We simply go to the editor, we look for these errors. We can also use the actual console log to find where is the error. If it's a runtime error, then it can be a bit more tricky, but again, we just go to the exact place. If it's a null pointer reference, it means that we are missing a component. If it tells us there's a problem on this line, this is probably the problem. This component is missing. So just go and make sure that this component is not missing in the inspector. Or maybe if you need to get it in another way. If it's an out of bounds error, then you're probably trying to access some kind of list or array that doesn't have this exact index. You're trying to enter an index that doesn't exist. And if there's something more complicated, like a bug or your code is not working correctly, then it's really not an error. It's simply your code not working correctly. So there's actually no way to create a tutorial about this, because each game will have its own functionality, its own logic. So if you're trying to make your player to run and he moves backwards, it's not an error. It's just a bug with the functionality of your game. And I can look at your code, but it's not an actual error. So it's not called debugging. It's just called writing your code and fixing your code and understanding your code, the logic. And that's the difference between errors and just writing proper code, writing code that will work. So I hope that this video was helpful. I hope that now you have a bit more understanding about how to tackle these errors. Simply divide this, try to understand if it's compiler errors, runtime errors, and then try to figure out where exactly is the problem. Then you can use the debug log to print out the values to the console, and then you can understand what is the problem. So that's all for this video. Thank you for watching. Please consider subscribing if you're still not subscribed. It will help me a lot. You can also leave a like for the algorithm, and I'll see you next time.